Thank you very much, and thank you for inviting me to this stimulating event. Thankfully, various other people have already spoken about things I will touch upon, so it's good that I don't have to start from scratch in many respects. So it will tie in with various other things we heard. Unfortunately, not every one of the previous speakers is here at the moment. So you see the title there, that's quite a mouthful, so I will try to explain to you why I put science and expertise there as different things, because that's the purpose of the talk. I want in some way to deconstruct the usual meaning of these terms. So what I will do is, first of all, question the use of these roles that are often used synonymously. I don't say there is a right or wrong definition, of course, but I will try to argue, convince you that there is much to be gained from the reconsideration of these commonly used terms. Then I will look at the scientific consensus, where it is and what it means, and at the disagreement, and then I will look at the expert consensus and ask if there is such an expert consensus above all, and then where the disagreement lies and what this all means for climate policy. So the background of the talk is, has been laid out in publications. One I did with Nico Stehr, which is the blue book there called Experts, a fairly short book published by Routledge a few years ago, in which we developed this notion of expertise, which I now develop further. So there's a book project in the making. I had recently a paper in Minerva where you see the first signs of this further development, which is called The Problem of Expertise in Knowledge Societies, where I critically review some influential contributions from the literature, mainly from science and technology studies. So this was published in September, I think, online. So this is the sort of background to the talk. The talk doesn't exist as a paper. I hope I will be able to write it up in the near future. So when I say we should reconsider these roles and what they mean, I think we all can come quickly to an agreement what scientists are. And I put there a sort of commonly used definition that it has to do with systematic pursuit of knowledge, right? Some people would say scientists try to find the truth and so on, which is all a much more ambitious definition. I think this general thing will do here. But from this definition you also see that there is not much implied in terms of giving expertise. If you create knowledge for knowledge's sake, you know, there can be theoretical knowledge that has very little applicability. There can be practical knowledge that is not very applicable in some instances. So, you know, we are really left with a puzzle here in what, you know, if you ask the question, well, how could scientific knowledge be useful for applications, in this case in policy terms. So if we as many people tend to think that experts are scientists who give advice, we are narrowing the range of possible voices of expertise to one particular role in society, and these are usually university scientists or scientists working in research institutes. On the other hand, not every scientist wants to give advice as an expert. I would say it's a very small fraction, and some of them are not asked. Some would like to do that, but are not in the position to give advice because they are not called upon. So there is various different constraints mean that we have to look for a better definition of what experts are. That's the argument. So two groups that we know about in the sociological literature, the old group of so-called professionals is also an expert providing bodies of expertise. And the other is what I call field expertise, which is growing from below, which some people call lay expertise. I don't think that's a good term, because lay and expertise are on the opposite end of the spectrum, and an expert is someone who's experienced in something, and therefore people trust their judgment. So this has to do with trusting people's judgment. And they are judged by clients. So the sociological definition of expertise, I think, being an expert is being in a relationship to someone who wants your knowledge, who wants your advice. And they are judged by clients, not by peers. So peer review is immaterial to that. And giving advice doesn't require you to have a degree or to be an active researcher. So in the book we say experts are mediators, so they are between knowledge production and knowledge application. Some of the experts can be knowledge creators as well, so these are the scientists, right? But they give often expertise about things that have little to do with their research. So they are known to be good scientists and reliable people, and so good names, so to speak. And they are asked because people would then say, look, this eminent professor has said that we should do this, or we are right. Now, experts provide advice. I think this is crucial because you could say experts just identify situations or provide options. But if you look at it, most of the time clients will say, what does this mean? Tell me what we should do. Experts sometimes are uneasy about that and say, no, I can't do that, I won't do that, I only provide the options. But this is what makes expertise valuable, that they provide advice. So advisors and experts are, in my view, a much better match than to say scientists are experts. Now let's look at the science consensus first. So this is about what Hans von Storch usually calls the Holy Trinity of manifestation, detection, and attribution. Manifestation is that we see global warming of average surface temperatures. Detection is this caused by, can we say this has a cause like anthropogenic? And if so, can we attribute it to specific causes in our industrial society? So this is the science consensus as it is described in Cook et al. And other papers, which is fairly uncontroversial. You could say, even if you look on skeptical blogs, people don't argue about, there is no warming, or, I know there are some outliers that I would still say this has been all falsified, but this is widely accepted. Now the problem is, as we saw with the surface temperatures and other data, we know broadly what's going on. If you try to make the point in a detailed way, like proving it, it can be very tricky, and that's what happened with Cook et al. So they looked at the level of endorsement in scientific abstracts on the Web of Science, not at the studies that were doing attribution research, right? So this is a very small subset in the climate community that does this job. So they looked at how people refer to the scientific consensus about climate change, the consensus about warming, and that it's caused by anthropogenic factors. So Richard Toll has written very, very critical paper about that. And one of the interesting things there is that the previous study by Oreskes had 25% of those abstracts didn't provide a position for or against anthropogenic causation, but Cook has 66% had no position, which is a large number. So if you exclude that, you get really very strange results there. If you So you get, on the one hand, very high and very low-end results in that analysis. So this is a methodological problem, and there are other methodological problems about inter-coder agreement, and people, so it's all calculated how much time each coder would have spent doing the coding, and said, you know, you can't do that. You will be tired, you will be miscoding things. So the devil is in the detail, but you know, just this criticism about how you deal with the 66% no position is an interesting one, and I think much has been made about this 97% paper, but it's really problematic. So you could say, like Toll says, it's truly remarkable that there is not 100% agreement, because it's a sort of truism going back to the 19th century that CO2 is a greenhouse gas, and if you emit and keep emitting and the stuff keeps accumulating, you will get warming. So there is, you know, if you know these physical facts, there shouldn't be any debate about it on that level. So if you don't find 100%, you could say the method is somehow problematic anyway. So there seems to be some kind of hand-waving reference to anthropogenic global warming in these abstracts. But the people who write these papers are no experts in attributing anthropogenic causes to it. Now, the problem with, so Cook et al. Say there is 97% consensus in the science community that the public doesn't get it. So this is American public, right? US public. There are many people who don't see it that way, and that's the gap that we need to fill. But this is why you should be doing something in terms of public engagement. Assumption being, people need to get the science, and then they will demand better policies. But this is the assumption that is behind that. There's also the assumption that this will be somehow unproblematic. So if people demand, if people are enlightened, then they will demand something and then policy will follow. But it's still not clear what policy. And it's also not clear what other fields there are in science that could be controversial, right? But this very general and superficial agreement doesn't get us very far. So I've looked at some cases where you could say there is science disagreement, and we heard just before lunch that science is uncertain, even with global surface temperatures. So you can't have 100% certainty in, if you want to say we've measured that and we are absolutely sure about it. So one of the crucial issues is weather extremes, right? So people make the comment, what we see now is an expression of climate change. Any kind of freak weather event, hot or cold, is used on both sides of the political argument, that a cold winter or cold summer proves that global warming is a hoax, or an extreme weather event that is hotter or more rain and so on is proof that the theory is right. Climate sensitivity has been also talked about yesterday in a very interesting talk, so I will show you something about that. Negative emissions is a big debate linked to geoengineering, and there is also debate about adaptation and mitigation. So I will just show you a few statistics from the Web of Science. If you look at these, so I say selection, I'm open to suggestions, what other fields there might be, so these were the things that came to my mind. So if you look at Web of Science, and I searched for climate change and extreme weather, or weather extremes. That's the top field that has been developing. You see, all of them are basically picking off after 2005. Geoengineering is the second largest growth branch, and climate sensitivity third, and negative emissions last. So if you look at that in more detail, you see sensitivity goes up there really in the last year, so after 2005. I didn't include any 2016 because it's not finished yet. So we are not at the level of this at the moment, so you would see a dip until now. But it seems to be going up. Geoengineering, up and down, the two peaks, 2009 and 2013. I'm subscribed to an email list where I tend to get a dozen or so every day. I can't keep up. I can't even read the headlines. But there is a lot of discussion going on there. Steve will know better what they are talking about, but this is an active field of research, clearly, with many different opinions in it. Negative emission seems to have plateaued. I don't know if this will pick up again or if this is overlapping with geoengineering. And interestingly, adaptation seems to be much more important. Well, it's mentioned, so this is a very crude measure. You just look at which of these words will be mentioned, and this seems to have become more important in research compared to previous years. Again, you see it's taking off after 2005. So let's go through those in more detail. So climate change and weather extremes first. There was this post, Roger Pielke Jr. was mentioned several times here, was invited to write for Nate Silver's famous blog 538, which he did, and he pointed out that several people think there is proof of climate change because we have increasing costs of extreme weather for insurance companies, and he pointed out this is not the case. We have increasing costs because we are richer, and if damage occurs, that's more costly, and we tend to build in areas where you shouldn't be building and so on. We heard about that already yesterday. Now this, of course, is a bone of contention, always has been, and ultimately I think this is why Roger had to pack his suitcase and leave that website, and he decided to leave climate debate altogether, because the message was not digestible to the mainstream. So Carrie Emanuel wrote a reply saying, you know, he used questionable methods there, and what he didn't realize was, what Pielke didn't take into account was the increasing risk of climate change, because we are still emitting, so the chances of something happening will become greater as we go on, which is something Roger agrees with. So this was a sort of strawman argument, I think. So Emanuel says this is not a good analysis, and well, if you look at the number of hurricane landfalls, this is what Roger did. I'll show you the graph here. You see, this is the stats, NOAA data. You see no increase in landfall hurricanes in the US. So Emanuel said, okay, but there is lots of other things going on, like hurricanes in the open sea, hurricanes not destroying anything. Which might be right, but the argument was about, does this damage that we see in insurance numbers tell us about climate change? Now, intensity of hurricanes, another statistic, 2005, Katrina was a peak there, but otherwise not a big development. So what does the IPCC say? about, so you see, I don't know if you can see that everywhere. On the left-hand column is the change of phenomenon, so you get everything to do with temperatures has been likely or very likely since the third assessment report. So the third assessment report is there, then the fourth, and then SREX, which is special report on extreme, can't remember, it's a very long title, on extreme events and something, which was done before AR5. Okay, so this is all uncontroversial stuff here, so you could say very likely. And then there are the projections for 2100, so this part here, this panel is about the mid-20th century, and then the projections. But this one is about observation, this is about projection, and it becomes more likely and more certain as we move on into the future. But if you look at tropical cyclone, you know, third assessment not observed, the fourth said likely in some regions, and SREC says low confidence, but then it's more likely in the future. Okay, so I guess nobody would disagree with that, given what we know about the physics of the climate system. And Roger is not on record and saying because it hasn't happened yet, it will never happen. That up till now there is no evidence. Now let's look briefly at the technical summary. In AR5, you see there's low confidence about long-term changes in the tropical cyclone characteristics, changes in drought, cyclone activity, Antarctic warming, Antarctic sea ice extent, Antarctic mass balance. Confidence in attribution to human influence remains low due to modeling uncertainties and low agreement between scientific studies. Several components of phenomena in the climate system could potentially exhibit abrupt or nonlinear changes, so this is the tipping point literature, but for many phenomena there is low confidence and little consensus on the likelihood of such events over the 21st century. So this is the latest report from the IPCC. So I think, if anything, that validates Roger's point about you can't see climate change in the hurricane data. Right? If you look at the physics, you can see it in insurance losses. Well, you can see something in insurance losses. The question is, was this caused by climate change? Now, on to climate sensitivity. So we heard yesterday different ways of doing that. It depends on the methods. I didn't know what these were, so thanks to your talk yesterday, this has become much clearer. I knew that this 1.5 to 4.5 was a sort of established range in the literature. There is a famous sociological studies in STS, I think from '96. Brian Wynn and Jerome Ponderslois interviewed scientists, and they told them at the time that this range was always unstable, but it was used as a sort of artifact to communicate to politicians, because otherwise the politicians would have said, you keep changing that range, that indicates you don't know. So they wanted to show they are pretty confident that this is the range, and even if the calculations were changing over the years, they would stick to it. So there was this exception when they went for a lower, for a higher lower bound, 2 degrees, I think it was in the fourth assessment report. So there are different methods. So observational methods come to much lower climate sensitivity. So best estimate 2 degrees. Yesterday we heard 1 degree, and even a little less than that is sometimes claimed. Someone called Richardson and colleagues point out that there are many flaws in the observation methods, and therefore you should, you should reconsider them. Now let me see if I can show you this, which I found Where is the link? No. So there is a link to the Independent. This is a little clip. This was done after Trump was announced, won the election, and lots in the climate community, many people think this is the end of climate policy, maybe the end of the world. But there is the claim that I think it's 6 degrees or 7 degrees we could see during our lifetime. And they quote Michael Mann. I searched for it, I couldn't find proof. I can't see it on Twitter because he has blocked me. So I asked people on Twitter if they think this is real. I didn't have a reply, but the Independent says this is what Michael Mann said. So some people claim we will see runaway temperature development during our lifetime. Now the problem with why is this so important? So if climate sensitivity is close to 1 degree, that would be good news if that was true, and we could be sure, because you don't need much of climate policy in that case. We doubled CO2 pretty much without much consequence in terms of environmental impact. However, if we are wrong, then the costs will be going up disproportionately the higher the temperature will rise. So unless this can be narrowed down confidently, there is this uncertainty, and it's the huge cost that poses the problems in terms of public policy, and we can't exclude the huge cost. So there's a good paper by Zeckhauser and Wagner who deal with that. They don't take into account the lower climate sensitivity. They just take the IPCC and say 1.5 to 4.5 is what we are dealing with. Okay, negative emissions. So there was someone on Twitter retweeting a UN Environment Emissions Gap report that should cause concern. But the message was we are moving in the right direction, but we must accelerate action. And Oliver Geden, who is of course always critical about such claims, says we can't really do that without negative emissions. The goals that are shown there cannot be reached unless we include some kind of large-scale technology and take CO2 out of the atmosphere and use large areas of the continent for bioenergy, which is problematic. So you would change licenses in India or Africa, or where you could plant crop, for example. So he says this shows exactly the opposite, and we have a huge problem until 2030 based on current business. So let's move on to geoengineering. There are various technologies here, and of course different scientists and different engineering groups have a horse in the race, and they favor different things. So there's cloud seeding, CO2 air capture, reflective aerosols, and so on. The problem is partly ethical. Are we allowed to do that? What if this has side effects? What if this is irreversible? And so on. But you could see how this fits into our existing industrial world, because it would be another, if it works, easy. The technological fix, we know what a technological fix is, and so people would make money from it. We could carry on as we do, and so you can see the appeal this has for policymakers. Agency, of course, is a problem. Who should be doing this? Should this be done through the UN? Could this be done unilaterally through the US or a developing country? These are all unresolved questions. I know there are various interdisciplinary research projects underway where you need to have all these different competences together. Who is responsible if something goes wrong? What is the scope of these technologies, and what are the timescales? So is this something you will put up and then roll back at some point? So these are all challenges and open questions which tell you that this is probably not very likely to happen, on the other hand. So on the one hand, it fits in with our thinking and our technological infrastructure. On the other hand, it's nearly impossible. Okay, now let's look at the expert panel. So I talked about the science, now the experts. So remember, these are people who mediate between knowledge production and application. They give advice and so on. They don't have to be scientists. The first question is, so the IPCC surely is the expert body. Everybody tells you about climate change, go to the IPCC. Now, is this an expert body? It says it wants to be policy relevant, but not policy prescriptive. This may have to do with the history of it, the origins, where scientists and politicians came together with different interests. The scientists said this is a unique opportunity to speak with one voice and get us onto the stage about an important problem where we know there is a problem. Politicians, however, thought we don't want the body that tells us what to do. We want to keep that under control. But this is a highly unique thing. Has no parallel in another policy area where governments and scientists write the final report and have a line-by-line approval process. Okay, so it's an intergovernmental body, not an international body. Never forget that. But there is clearly the political control over what is going on. And if you look at the wording, that's really weird. Policy relevant, but not policy prescriptive. What about policy options, policy advice, policy recommendations? Isn't that something such a body should be doing? It's not mentioned. So how much advice does it give, and how relevant is the expertise for policy making? We do have working group 2 and 3 where you could say they deal with that kind of stuff, but they are usually mentioned in passing only if you look at the press and the public debate. The public debate is full about these graphs that you have seen about warming, about extreme weather events, and so on. So the argument here is, if you think about experts providing options and giving advice, they are unlikely to agree. I had some fun doing these little notations there with the number of the groups of experts and advocacy of policy proposals, and they are roughly the same, but probably the groups of experts is smaller because there's this overlap between different technologies and different policies. But what you don't get is that there is an equal number, that you have one group of experts that is in favor of one group of policy options. That's highly unlikely, and I think we heard about that in the talk about Norway. There are always very many policy options on the table. And that's the nature of expertise and expert disagreement. So expert disagreement is something to be expected. You have policy options. In this case, economists would always say you need a pigou tax. This is a sort of dogma for them. Regulation and other things like subsidies are, of course, also implemented, and we have loads of them already. Climate policy could be a byproduct of other policy measures. If you think about clean air, transport or energy policies. Some people say we must not forget other drivers of the climate system, N2O, methane, changing patterns of land use, tropical deforestation, and so on. HFCs might become regulated now under the extension of the Montreal Protocol. So there is lots of different options that are pursued by experts, and it's unlikely that you will find experts that would say, okay, let's do all of that. You usually get a sort of dividing line there, and people would advocate one of them or a couple of them. There's a big divide about nuclear energy. Is this a green technology or not, given climate change? Even in the green camp, carbon capture and storage, gas, so fracking, big divider. Now this BECCS technology, which is bioenergy and carbon capture and storage, this is Geden's argument, Oliver Geden saying, this has been factored in to reach the Paris Agreement silently. There is no debate about it. But this, without this technology and approach, we are not able to reach the target. Now, just focus on mitigation and adaptation. The problem here is, so whenever I said in conferences with climate scientists that adaptation is not being taken seriously enough, people would say, but we need to act before it's too late. And poor countries can't afford it. To which, of course, the first answer is, in some sense, it is too late. We have released these gases. They are there. If the theory is right, we will see consequences. We have to adapt. So in a way, you can't, this is not an alternative. There's no choice. You have to adapt. And the argument about poor countries not being able, I don't know, but if this is a 100-year perspective, you know, economic development in other countries, countries changing their priorities, just assuming that India or Bangladesh are just too poor to do anything with our help is a questionable stance to take, I think. Okay, so I said yesterday it's problematic to assume that you get good policies if you have a scientific consensus, or good policies do not necessarily follow from sound science. So this is based on a book I wrote with Nico Stehr. 3 case studies in that book: race science in Germany in the 30s, climate change, and Keynesian economic policy. 3 different cases and different success, different influence on policy making. The result is you can't generalize from that, of course, but the link is very tenuous. So you shouldn't assume that scientific consensus will translate into policy consensus or policy making at all. Even if you accept a scientific consensus, put it into policy decisions, the problem is implementation. So this is something that in the climate debate was always sort of neglected. If you had a global treaty, how would that translate into national policies, and how would national policies implement these targets into their legislation and into effective changes on the ground? So there are limits to what I call voluntarism. It's not enough to say we will do it, we can do it, and we make a law and this is it. There are hundreds of ways of subverting it, and the implementation literature shows you that the structural constraints are so great in many cases that the implementation is not going to plan, and then new political options come on to the table, and other items are being discussed, so you get a shift in priorities. I'm not saying this will happen, but it could happen. So, before wrapping up, what are we left with? I wrote a paper in Nature Geoscience this summer, an opinion piece, which I called Climate Change as a Wicked Social Problem. We heard about wicked problems from Steve, who has just left. And so the argument is, this is really a social problem and not a science problem. You can imagine that the scientists are not happy about that. So I had lots of discussions on blogs about it. People accusing me that I'm not even a scientist. Missing the point completely, of course. But if you think these problems have to do with policy responses and implementation, climate science is not the right body of knowledge to deal with it. So this goes back to someone called Charles Lindblom, classic in public policy literature, who said, many people think before we make policies, politicians should have a synoptic view, a bird's eye view of every possibility that is theoretically imaginable, evaluate these, come to a conclusion, and then implement that policy. And he says in practice this is never happening, and everybody knows, and it's a surprise that people pretend that this should be happening. So he says we are muddling through all the time, we only can manage better or worse. Only manage better or worse. This is what I think happens everywhere, in every social problem, and it happens with climate change. So just to conclude, I think many people in the room have made the point that uncertainty in this area persists on various levels. There is another famous paper by Reiner in the 70s who said, this is trans science. So how can we make decisions if uncertainty exists? He says, trans science deals with answers to questions which can be asked of science and yet which cannot be answered by science. So this is the condition, I think, that applies in this case. So climate scientists think they have to contribute something despite the uncertainties. There is a leap to be made from saying this is the problem and this is how I think it comes out, to then giving advice and saying this, therefore we should be doing this. So the consensus doesn't determine policy. I would even say it's partly irrelevant. I had a coffee conversation with John about that, so we talked about Ireland, Germany, US, we could include the UK. So Ireland has a policy consensus but does nothing. Germany and the UK have a policy consensus that it's important and are the self-proclaimed leaders. If you look at the data, they haven't decarbonized very much. The US has always resisted that, partly fiercely, but have effectively decreased their carbon intensity through shale gas revolution. So they were, it's a highly ironic outcome if you look at the pure outcome of decarbonization. So this is a real, hopefully it doesn't give you a headache, but this is sort of a conundrum we are left with. So more scientific research will not lead to more policy progress because the scientific consensus does not lead to a policy consensus. Expert knowledge is needed for climate policy, but the experts are divided. So even if you said there's scientific consensus, doesn't lead to policy consensus, expert divided. So how do you get a consensus out of that? I think the answer is you need to have different kinds of knowledge that will be applied. You need to be pragmatic. You need to identify what is possible in different regions and different countries of the world. There is no global solution to this problem on the policy level. So if you want to know how to do these policies and implement them and study likely resistance or things that would enhance your chances of being successful, you would need a healthy dose of social science in this process and turn attention away from climate science as a policy solution. Thank you.